Okay, Ellie, I just said we're going to go through each one of these problems really, really super fast. And I'll slow down on some of the hard ones. So here we go. Number 1, in decimal form. We want degrees, minutes, seconds in decimal form. 43 is going to be the overall big decimal, and then I need 4 decimal places after that. 3 divided by 60 plus 56 divided by 3,600. Add that together in your calculator, and you should get 0.0656. Questions about that? Moving on fast to B. Yeah? No, number 2. Good? Number 2 is now in degrees, minutes, seconds form. We want, or no, is now in decimal form, degrees, minutes, seconds. So degree, minute, second. He's ready to go. 10 goes here. I don't even have to do anything, and I know the 10 goes there. Then I take 0.5625 and do what to it? Times 60. We're going the opposite direction. If you take that times 60, you get 33.75. And that means 33 goes there. Then what? Take 0.75 times not 3,600, 60 like you guys said, okay? Over here we were dividing by 60, divided by 3,600. You guys understand why we only do 60 and 60 this time?
Because 60 times 60 is 3,600. Right?
True, and this guy right here was already multiplied by 60. It's like the 75 or the 0.75 was a part of this decimal that got multiplied by 60 already, okay? So if you multiply by 60, you get 45 seconds. Yeah?
Very cool.
45 seconds. There you go. Degree, minute, seconds.
And then 0.75 gets what?
0.75 times 60 is 45. Woo! Okay?
Wait, what are the little...
3?
Yep, you're good.
3. Converting from pi to from radians to degrees and degrees to radians, the conversion is times either pi over 180 or 180 over pi. Which one goes for part A? 180 over pi. So pi is going to go on the bottom, and I'm just going to take 11 times 180 divided by 5, and you should get 396 degrees. Not too bad, right? Do the same thing here, times 180 over pi, and you should get negative. Don't forget the negative. Negative 315 degrees. Questions about that?
Did you go on the A?
396. I'll zoom out. Okay, 40 degrees. I'm going to make that into a fraction, 40 over 1. This one I'm taking times pi over 180 because I want the degrees to cancel. Okay, I'm also going to reduce a 0. And I have 4 pi over 18, and which reduces to 2 pi over 9. Some of you guys have that in decimal form. I'll take it in decimal form. I'll be nice. I'll take it in decimal form.
Thank goodness.
Okay? Over 1 times pi over 180. Degrees cancels. If you divide by 5 and do all of the things, you get negative 35 pi over 36. Yeah?
Yeah.
Negative 35 pi over 36. That's what he should be for D. Good? Was that too fast?
Nope.
Was that okay? Okay. Number 4. I need an angle between 0 and 2 pi. This guy right here, how do I know he's not between 0 and 2 pi?
Because he has a pi.
Well, he has a pi. How do I know he's not between 0 and 2 pi, though? What is 21 divided by 5 as a decimal? 4.2 pi. I want it to be smaller than that, right? It needs to be between 0 and 2 pi, so I'm way too big. So what I'm going to do is I'm going to subtract. And when you're finding coterminal angles, you're either adding 360 or subtracting 360, except when you're in radians, you're adding 2 pi and subtracting 2 pi. So I need to subtract 2 pi. If I have a common denominator, 5 and 10. 10 pi over 5 is the same thing as 2 pi. Yes? If I subtract, I get 11 pi over 5. Is that between 0 and 2 pi? 11 divided by 5 is 2.2. Still not. So I'm going to subtract another 10 pi over 5. And that is 1 pi over 5, or just pi over 5. Is that between 0 and 2 pi? Yes, it is. 1/5 is 0.2. 0.2 is the number between 0 and 2. Good? Okay, I'm going fast. This one is negative, okay? 25 over 3, 25 divided by 3 is 8.3 repeating. That's 8 1/3 pi. I have to add lots of them, right? So I'm going to add 2 pi, but with a common denominator of 3, I need to add 6 pi over 3, right? 6 over 3 is 2. Okay, negative 25 plus 6. Negative 19 pi over 3. 19 divided by 3 is still a number that's bigger than 2. So I'm going to keep, well, I need to get it positive anyway. I'm going to add another 6 pi over 3. Okay, and that makes how much? Negative 13 pi over 3. I got to keep adding. So add another 6 pi over 3. What's that? Negative 7 pi over 3. Add another 6 pi over 3. You get negative pi over 3. We're so close. Add another 6 pi over 3. And now we get 5 pi over 3.
6 pi's did you add?
We added 1, 2, 3, 4, 5. Huh. That's a lot. Okay. You did it the fun way. Hey, that works too. Did you hear what Michael just said? It's the long way. He said, I converted it to degrees, then added 360 a bunch of times, and then I converted it back to radians. Totally fine. It's the long way around, but you know, that works. Okay, good? All right, let's do 6 before 5. 12 revolutions per minute. I'm going to do this. Let's do train tracks. 12 revolutions per 1 minute. This is a train track. We are going to, and I guess you guys connect them, right? You do that? Railroad. That's what railroad. Whatever. Railroad tracks. Whatever. Okay? Revolutions per minute, but I want it in radians per minute. So minute gets to stay minutes, but we need to change revolutions to radians. I need revolutions to go down here. How many radians are in a revolution?
2 pi.
There's 2 pi radians in 1 revolution. So 12 times 2 pi is 24 pi. And my units, my revolutions cancel off, is in radians per minute. Do you see how that works? 24 pi. I also have 75.4 if you want the decimal. 75.4 radians per minute. I will take that also.
You just know this off the top of your
I have it written down on my cheat sheet from the game the other day. And I know it off the top of my head. That's a lie.
Like, you're just pulling
Just
numbers.
kidding.
Like,
Just kidding. Just kidding. Okay? Happy with that? Number 5. 2 minutes and 20 seconds. We're talking about the second hand. 2 minutes is going around twice, right? So let's just think of this in degrees. If I go around, if 1 minute is equal to 360 degrees, true?
140.
Okay, so in 2 minutes, I've gone 360 plus another 360. Agreed? 2 minutes, 360 plus 360. 20 seconds. What fraction of a circle is 20 seconds?
A third.
Yeah, there's 60 seconds all the way around. Okay, so 20 seconds would be like just a third of that, right? And what's a third of a whole circle in degrees? 120 degrees, right? So I've gone an additional 120 degrees on top of that. If I add those all together, that is like 840 degrees. But I want it in radians. Can we convert from degrees to radians? Sure. Over 1 times pi over 180 degrees, and you get, my degrees cancel off, my 0 cancels out. 84 pi over 18, I can divide by 6. 14 pi over 3. Or also 14.66 radians is the same thing. Okay? Was that confusing? I can back up and re-explain if you need me to. 1 minute is a whole circle, so 360 and 360 again because that's 2 minutes. 20 seconds is a third of a circle. So that's 120 degrees. Add them up. Convert. A third of 360 is like 360 divided by 3. So 120.
So then we add 120 to that.
Yep. 840 and then do all the thingy things. Okay?
So 840.
Good?
And we would do what? Times
180. Pi over 180. 14 pi over 3 or 14.66. All right. 7 and 8. 7 and 8. Radians per minute. We're doing angular speed and linear speed. Okay? Write this down. Angular speed is equal to speed in radians per, I'm going to say time, because they will have to tell you the unit. So radians per second, or radians per minute, or radians per hour. I have no idea, right? That's what angular speed is. Linear speed, which is what we're doing in part B. Linear speed is equal to the angular speed times the radius. Okay? All right, here we go. A bicycle has 25-inch wheels in diameter. So all the way across is 25. That means my radius is how much? 12.5. Okay. Which turn at 80, what's RPM mean?
Rates per minute, or reps?
Revs per minute, revolutions per minute, okay? That's not the same thing as radians per minute. So all we have to do for angular speed is take 80 revs per minute, do the train track things, railroad tracks, whatever, and minutes gets to stay, but we need to convert revs to radians. So 1 rev is equal to how many radians? 2 pi radians, yeah? Okay, 80 rev, or my revs cancel off, okay? 80 times 2 pi is 160 pi radians per minute. Or you can convert it to a decimal, whatever you want. It's 502.65. I don't care. And that's in radians per minute.
When is this test?
Tomorrow. Tuesday.
Yes?
Tuesday or Wednesday. One of the two.
Tuesday, Wednesday?
No.
No?
Probably Tuesday.
Yeah.
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 Mm-hmm.
Okay.
Why? Why
Oh.
Tuesday?
Tuesday.
What?
Tuesday.
Tuesday.
Why Tuesday?
I like
Is there something going on next week?
Tuesday, some people are gone Tuesday.
Who?
For what?
What are you talking about?
Track or, yeah, track. You guys are not gonna have a track meet on Tuesday.
Yes,
Yes, we are.
Huh?
We can run in the
What are you,
snow.
I hope you're right. Read the Farmer's Almanac.
Whatever.
One time that the
Whatever.
was steaming because Mother Nature couldn't decide what it
That was
wanted to
at
do.
Franklin.
Yeah, it was.
All right, here we go. Linear speed. Linear speed is just wanting everything in inches per minute. Here's the deal. Let's say I don't know the formula. Let's say I don't know that you just take the angular speed times the radius, okay? So I'm going to take what I had, which was 160 pi radians per minute, right? And I want inches per minute, okay? So what I need to do is I need to swap out the radians for inches, yes? But 1 radius, which is the same thing as a radian, a radius and a radian is how many inches? 12.5, right? So radius cancels with radius, and it is the same thing as taking the angular speed times the radius, and that gives me the linear speed. Do you see why that is? It's just another train tracky thing. Radius cancels with radians, and then you have inches per minute left over. What is that answer as a decimal? 6283.19
And so
inches per minute.
160 radians per minute
Yep.
times what? 1.5 radians for what?
Per minute. Okay, real quick, before we move on to the next one, here's the center of my circle. Let's say I have a fleck of dirt that's on this little spoke right here, and I have a fleck of dirt that's over here on this little tire right here, like on the outside of the tire. Which one has a faster angular speed?
Outside the tire.
The wheel.
The same.
Oh, wait.
The angular speed is going to be the same. It's moving at the same angle no matter what. Which one has the faster linear speed?
Outside.
The outside's covering more distance, right, as it goes around, so it's going to have a faster linear speed. But the angle of each is moving at the same all the way around, right? So the angular speed, no matter where you're at on the tire, you have the same angular speed going all the way around. Linear speed, you're going to be whipped around faster. It's like sitting on the outside of a, what are those things called? Merry-go-round. The outside of a merry-go-round, you're going to be like whipped around a lot faster than if you're sitting in the middle of the merry-go-round, right? Okay? Linear speed versus angular speed. The angle's moving at the same rate the whole way around. Doesn't matter where you're at, right? Okay, same thing here. That's what they're going to ask here. A circular paddle wheel has a radius of 3 feet, okay? Radius is 3. Draw a picture. The current causes the wheel to rotate at a speed of 12 radians per minute. Do you guys know what this thing is? This is like how they generate electricity like in the olden days. Maybe they still do, right? So there's water below, and then it has like little slots in here, and the current moves the wheel, right? And then it like turns it, makes electricity, whatever, you know. Okay, so this is moving at 12 RPM, angular speed. I want angular speed in radians per minute. This is in revs per minute, right? Okay.
So just take it times
1
2
rev is the same thing as 2 pi radians.
is 24.
24 pi radians per minute. Okay, that is the angular speed, or whatever that is. 75.4. We already had that one.
Yep, at the top.
Yep. Okay, 75.4 radians per minute, whatever. Find the speed of the current in feet per minute. What are they asking for there? Linear speed, right? Okay, I want speed of the current in feet per minute. So right now I am at 24 pi radians per minute, right? So if you want to keep doing the train track things, I keep calling them the wrong thing. 1 radian is equal to how many feet? 3, right? Then my radians cancel off. It's angular speed times radius, right? Or just use the little train tracks, whatever. 24 pi times 3 is how much feet per minute?
2 carry the 1, 6, 7, 72.
226.2?
What? 24 times 3?
24 pi times 3.
Oh, I was like, what?
Is that true? 226.2 feet per minute?
6.2, yeah.
That's feet per minute. 226.2 feet per minute. How many miles per hour? Do you know how to do this?
5280.
Feet to miles is 1 mile to 5280 feet, yeah? Okay, I want to convert minutes. Does minutes go on the top or the bottom? Top, because I want minutes to cancel, right? And then this is hours, okay? 60 minutes per 1 hour. Do you guys know how to do that? Yes, yes, okay. Feet, so now I am in miles per hour. So this times 60 divided by 5280. And you get 2.57 miles per hour. Does that seem appropriate for the speed of a current? What would be inappropriate for speed of a current? It's not going to move as fast as a car, true? So like 100 or even like 50 miles an hour. Like I don't think that's going to be right unless we're like going off of a waterfall. You know, like that might be 50 miles an hour.
Yeah.
I don't know. But a current's not going to move that fast, okay?
What do you know about currents?
I know enough to know that that is an appropriate answer, and 50 miles an hour would not be appropriate for a current unless we're doing like a little waterfall thing.
2.57 miles.
Okay. 9. I'm going to do 9A and 10A, and you're going to do 9B and 10B if you haven't already done so. Here's my circle. 130 for 35 degrees. How big is that, approximately? What quadrant? What quadrant? Second, 135 degrees. They want to know the length of the arc. So I want to know how big this crust is. And that has to do with the circumference, right? Distance around circumference. How do you find circumference? 2 pi r, or diameter times pi. They say the radius is 10, so my diameter would be 20. So 20 pi is the entire circumference, except I only want 135 out of 360 degrees, and that is like 23.56 centimeters. Okay, you do the other one. If you are not already done, do the other one. And then we'll talk about those two answers and how you know you did it right. Okay, don't look at mine.
Too late. I just did.
Did you get B? 1.99? 1.99 is awfully close to the radius, right? 1.99 versus a radius of 2. Why is that? What?
It's 57, not
1 radian is how many degrees?
57.3.
1 radian equals 57.3 degrees. I did that on purpose, right? So that you could see I'm going about 57 degrees. So it's going to be about the same as what the radius was. This one right here, the other one, if 1 radian is 57.3 degrees, how many radians have I gone? If I'm going 135. About 2.5, right? I'm going 2.5 of these. What's 2.5 times 10? 25, or 23.56. It's not quite 2.5. Okay? Do you see how that correlates? Okay? So maybe hopefully do some of that stuff in your head. All right, find the area of each of the following sectors. Now we're doing area. How do you find area of a circle?
Oh, pi r squared.
Pi r squared. That would be the whole circle, right? Okay, the radius is 3. So pi times 3 squared is 9 pi. But I only want how many degrees of it? 120 out of 360. Now some of you guys brilliantly did this. 120 out of 360 is 1/3. And what's a third of 9 pi? 3 pi. Or 9.42 centimeters squared because it's area. Okay? You do B. Did you get that? 31.4 or 10 pi meters squared for B?
I guess.
You guess? Beautiful, beautiful, beautiful.
10 pi?
Scroll. Yeah? Maybe? Hmm? Okay. No? To the back? To the back. To the back. All right. First things first. 6 trig functions. What do we need to do first before this triangle?
Sine, cosine, tangent.
Right? We need to write out sine, cosine, tangent. So I'm going to do sine, theta, cosine, theta, tangent, theta. Kind of big. Then we need cosecant. Do you guys remember which one goes with which?
Cos goes with
Ooh.
sine. Or, wait.
Secant, cotangent. Ah. Daniel's like, I don't know what you're talking about.
Oh my gosh.
It didn't suck.
Yes, it is.
Ah.
I didn't try
Okay, now what do we do? Now that we've written them all out. Find the hypotenuse. 4 squared plus 7 squared equals c squared. 16 plus 49 equals c squared. 16 plus 49 is 65 equals c squared. We're just going to leave it as the square root of 65. Does that break down?
Nope.
We're just going to pretend it doesn't, even if it does. The square root of 65. Now, be careful.
So get the what?
We're doing this angle at the bottom here. 7 is which side?
Opposite.
Opposite. What's 4?
Adjacent.
Adjacent. The hypotenuse is 65. Okay, so sine is SOH. He goes
So
7 over the square root of 65, but you need to
7
rationalize.
square root of 65 over 65.
Yep, 7 square root of 65 over 65, yeah? Okay, that's sine. Cosecant, flip it. Hold on. Cosecant, flip the original. So the square root of 65 over 7, yeah? Cosine, adjacent over hypotenuse. 4 square root of 65 over 65. Square root of 65 over 4. That's cosine and secant. And then tangent's nice. Opposite adjacent is 7 over 4, 4 over 7.
Oh, nice.
Yep. How nice. Very good. Questions about that? Okay. All right. Now, you will be surprised. A lot of questions below have to do with that same process. They just don't give you the triangle. Right? Like number 16 is that exact same question. Find the 6 trig functions. But they don't give you the triangle. Should we skip those or skip and do those right now? No? You want to go in order?
No, I don't like
Also, same thing. Number 20 does that exact same thing. But it just doesn't give you what the triangle looks like. But it's that same process. Okay? Should we go and do them in order? 12? 12 next? Okay? All right, find the length of side H. They say angle A is 50, so label these. And then the distance from C to A is 20. What's my strategy here? What can I do and can't I do? Can I do the Pythagorean theorem?
No. Well, you could if you knew what H was. But
Right, but
So-
that's, yeah.
could we do
Yeah.
sine of 50 degrees?
Can we do SOHCAHTOA?
Yeah.
Yeah?
Just have X in there.
Yeah, SOHCAHTOA. Okay, so I'm looking at 50 degrees, and I'm trying to solve for H, and H is
Opposite.
opposite, and 20 is adjacent. So we're looking at tangent of what?
50 degrees.
Tangent of 50 equals, opposite is H over 20. Now how do I get H by itself?
Divide.
Multiply by 20. 20, tangent 50, h is 23.8. Whatever units. Questions about that? That was really fast. Give us a bunch of those, right? All right.
23.8.
23.8. 13. When it says solve the triangle, what the heck does that mean? Find every side and every angle. Some of them they give to you, right? They have to give you 3 pieces of information always. But wait, Mrs. Komachu, they only gave me 2. 30 degrees is C and A is 10, but 90 degrees is B. That's what Ethan just said. What is A? He's a 30, 60, 90, you betcha. Okay, I'm going to put 10 here. A is 60, C is 30, and there is all of that stuff.
30, 60, 90.
You're going to do it. You could, so if you know it's a 30, 60, 90 and can remember like the shortcuts and stuff, which I don't know, did we do that in this class? We did it in Trig, or we did it in geometry. So like 1, 2, square root of 3, right?
I know.
That side,
But
okay.
Hear me out.
But if you don't remember, let's just do it this way. Which angle would you like to do? 60 or 30?
60.
Doesn't matter, but you got to pick one. 60? Okay, let's say you're solving for little b. And I want to use 10. 10 is?
Actually, can we use 30? 30 we were given.
Okay, doesn't matter. Doesn't matter. We could use 60 because we didn't round it. So that's fine. Let's use 30. What is 10 in relationship to 30? Adjacent. And b is? Hypotenuse. So we use cosine. Cosine of what? 30 equals adjacent is 10, hypotenuse is b. How do I solve for b when the b is on the bottom?
We know the hypotenuse is 10. Oh, because it gives us 10. I'd ignore that.
I switch them. So b is equal to 10 divided by cosine 30. And you get something like, I don't remember. What is b?
Hang on.
11.5 for b. Okay, now let's say we're solving for c. So I'm going to use the adjacent side. I'm still going to use 10, but I'm going to use opposite and adjacent now instead. So I'm doing tangent of 30 equals, opposite is, what do they call opposite? C over 10. Now how do I solve for c? Multiply by 10. 10 times tangent 30 is something small, or 5.77. Perfect. Okay, happy with that?
Isn't there a formula that's like sine this over this equals this over this?
Yes, that is for non-right triangles. That's what we're doing next chapter. That's the law of sines. Yep. I know you guys are all excited about that.
For this.
And you did get the same answer?
Yeah.
Yes, true. So the law of sines and the law of cosines can be used for right triangles, but you cannot use SOHCAHTOA for non-right triangles. So it could go the other way, but SOHCAHTOA can't be used for
It's like-
non-right triangles.
It's
Yes.
like a square is a rectangle.
Now,
Rectangle
SOHCAHTOA is
a
faster,
square.
probably, than sine or whatever. But it'll work. Doesn't matter. Okay? All right, this guy. We've got the little sides here. We've got A is 3, C is 7, and then we know capital B. So A, B, C, little a, little b, little c. I just usually fill these in. Yeah. 3, 7, B is how much?
90.
Oh, capital B is 90. How do we find little b? You can use the Pythagorean theorem, yeah. Little b is the hypotenuse, right? So 3 squared plus 7 squared equals b squared, yeah? 9 plus 49 equals b squared. This is 58 equals b squared. What's the square root of 58? I don't know.
Square
I just put the square root of 58. What is the square root of 58?
and square
7.62.
7.62. Perfect. Okay, now what? Would you want to solve for A or C?
Let's go A.
A. Okay. 3 and 7. I know this is 7.62.
6.
Which two sides do you want to use?
The side we didn't round on.
The side we didn't round on, the two that we were given to. So we have to use opposite and adjacent. And not this one, because we rounded that. All right, so we have to use tangent. Okay, tangent of what?
3 over
tangent of angle A equals opposite over adjacent. How do I get the A out of there? Yeah, I have to do the inverse tangent. So A equals inverse tangent of 3 over 7. Okay, and you type that in your calculator and you get for A like 23.2 degrees roughly.
For A.
Yeah? 23.2 degrees roughly for A. How do I find C now?
Subtract.
You just subtract. Or just subtract that from 90, right? 90 minus 23.2 is 66.8. Yeah. Okay, was that okay? Okay, 15. Where's Connor? 15. I got 15 wrong. And I kept telling Connor, you're wrong. That's not right, Connor. You're wrong. And I kept sending him back, and I felt terrible because he actually had the right answer because I had the wrong answer. And here's why. They give everything to you in feet, and then they say, how many miles is the airport from the ground below the plane, blah, blah, blah. So, be careful. All right, let's draw a picture. We have a plane. And it says it has an altitude of 22,000 feet. What is altitude, by the way? Straight down, 90 degrees to seafloor. 90-degree angle to seafloor. Okay, 22,000 feet is where we are at.
Draw your triangles the other way.
Oh, yeah. I mean, if you want it to, like, resemble in the first quadrant, yeah. But I don't know. It doesn't matter. It doesn't matter.
Draw them like that?
No. I just put them whichever direction. It doesn't matter. Whatever. And on here, I drew it the other direction. Whatever. All right. The angle of depression to a nearby airport is 24 degrees. Depression means horizontal down. Horizontal, like if the plane would keep flying, horizontal down is 24 degrees. Which means that the bottom right corner is 24 degrees as well. Yes? Because those are alternate interior angles. It all fits together. They are wanting us to find the bottom side. Okay, let's do it. 24, opposite,
so
adjacent, tangent of what?
24.
24 equals opposite, 22,000 over x. How do I get x by itself?
Divide.
No.
Well,
Switch them.
Yeah.
Anyone that
Divide by
participated in action stay yesterday, please go to Ms. Cleaver's room before 8th period. Thank you.
Mrs. Cleaver's room before 8th period, they said. Okay,
Too bad.
we'll be done here in a second. And then you can go. 22,000 feet divided by tangent 24. What's that?
49412.8.
Feet? But they want it in miles. So divide by 5280. And it's 9.36 miles. Yep. Beautiful.
Divide by 5.
Are you absorbing? Is this making sense to you as we go? Something like that? Okay.
9.36 miles.
You are getting smarter as we speak? Okay, I like it. 16, 6 trig ratios. This is the same thing as what you're doing for number 11, but they don't have a triangle drawn for you. They say through the point 6, negative 8. What shall we do?
Put him in a plot.
Let's plot the point 6, negative 8. 6 is to the right 6, and negative 8. 6, negative 8. I'm going to make a triangle out of him. We always make bow ties, not hourglasses. Right? Do you know what I'm talking about? Does that seem like a foreign concept?
No.
You understand what I'm saying when I say bow ties? Okay. Bow tie. All right. So this is 6. This is negative 8. What's this third side going to be?
3, 4, 5.
Yeah, he's a 3, 4, 5 right triangle. That shows up everywhere. Like all over the place. You have so many shortcuts that are 3, 4, 5s. This is 10. Is it negative 10?
No.
Positive 10 is the hypotenuse. Okay, now what I'm going to do is before we do the 6 trig functions, which are like sine, cosine, tangent, I'm actually going to reduce it, right? Because 6 over 10 is 3 over 5, right? So let's go ahead and reduce. 6 is going to become 3. 8 is going to become negative 4. 10 is going to become 5. Yeah? And then where does your angle live? What angle are we talking about? The one closest to the origin. That's where theta is. So I want sine of theta, cosine of theta, tangent of theta. Which one goes with sine? Cosecant. And then secant. And then cotangent. Okay? Sine is opposite hypotenuse. Negative 4 over 5. True? Cosecant, negative 5 over 4. Cosine, adjacent hypotenuse. What is that? 3 over 5. Secant, 5 over 3. Tangent, opposite adjacent. Negative. 4 over 3. Negative 3 over 4. Good? That was not a hard problem. You just had to draw the thing.
Hang on, don't move.
Good.
Don't move. Okay, you can move.
Okay. 17, find the exact value of sine of negative 5 pi over 3. That's on your unit circle. Except, I don't have a negative 5 pi over 3. So you could look where 5 pi over 3 is, and then you can go the opposite way that much, but I'm going to just add 2 pi to it to get it to be a positive angle. Can we do that? But instead of adding 2 pi, let's add 6 pi over 3. What's negative 5 pi over 3 plus 6 pi over 3? Is just pi over 3. Okay, so on your unit circle, find it. What is sine? Sine is the y-coordinate. And the y-coordinate pi over 3 is square root of 3 over 2? Perfect. There you go. On your unit circle. Negative 5 pi over 3 is positive pi over 3. Square root of 3 over 2. Good? Beautiful. Okay. 18 was not too bad. Cosine is negative, tangent is positive. Which quadrant are we in? Okay, so if cosine is negative, which two quadrants are cosine negative? Cosine, by the way, is the x-coordinate. So x-coordinates being negative are over here and over here because you're going to the left, right? Okay, tangent, I want tangent to be positive. That is in the third quadrant. Tangent's positive because sine and cosine are both, yeah, right, because I love that you use that, right? Tangent, if I put a line in there, the slope is positive. So tangent is positive in the third quadrant. And it's positive in the first quadrant. Tangent is negative in the second and fourth quadrant because it's going downhill. That's a weird way to think about it, but that's how it actually works. I like it a lot. So we're talking third quadrant. That's the answer. That's all. Okay, grab your unit circle for this next problem. We have 3 things to look up. Sine of pi over 2, sine of 0, and cosine of 0. Pi over 2 is 90 degrees. Sine is the y-coordinate at 90 degrees. What's the y value at 90 degrees? 1? Okay, at 0, what's the y-coordinate at 0? 0. What's the cosine at 0, which is talking the x-coordinate at 0? 1. So the answer is, that's not too bad. Okay, 20. What does this mean? And they had that on the ACT practice question the other day, and she didn't even talk about it. She didn't even talk about what that meant, which, I mean, yeah, she didn't even, yeah, and she didn't draw it in the right way. Made me mad. So, pi over 2 and pi, that means we're in the second quadrant. So I'm just going to draw a triangle in the second quadrant. Like that. That very much made me mad. Like, okay, fine, you don't need to talk about it because, like, maybe that's going to just confuse kids more than not. But at least put your triangle in the right quadrant, right? Where does T live? Like, where does angle T live?
In the origin.
In the bottom corner, and like in the origin, right? Cosine is negative 12 over 13. What does that help me do? Cosine is adjacent hypotenuse. So the adjacent side is 12. That's the bottom side. The hypotenuse side is 13. Which of those is negative? 12. Okay? And something 12, 13. What's the third side? 5, right? You could do the Pythagorean theorem if you wanted to. Is the 5 going to be a positive 5 or a negative 5? Positive, because he's going up, right? Okay? They just want, not all 6, they just want sine. So sine of t is equal to opposite over hypotenuse. 5 over 13. Yeah, I bet. Did you get any of them right?
I hope so.
Hope so. Okay. All right, there you go. Good? How about that?
Great.
Nope.
All right. I have a second half for you, and it's the graphing half. Do you want to wait till tomorrow? Do you want me to give it to you now?
I wanted to let this one.
Reese wants it now.
Let this one,
She's
faster.
biting at the bit. She wants it now. Reese can. But then if we play a game with it, like her team will win. Just kidding. Oh, does anybody else want it now?
I'll take it.
Okay. All right. I'll give it to whoever wants it. That's what it looks like. It's all graphing stuff. And mine's fuzzy for some reason. That was not very nice. Okay. All right. There you go.